Hi, I'm Adam. Welcome back to GodotGameLab. In this video, we'll take a look at single targeted cards. First, let's see how they work in Slay the Spire. So if I start dragging this card to the card play area, two things happen. The card pops to the center of the hand on top of all other cards, and an aiming arrow appears to guide us. When I hover over an enemy and left click again, or I just release the button, the card gets played and the enemy dies. Cancelling this aiming state works very similar to the other cards. If I right click, it goes back to my hand. Also, if I release the card while dragging below the play area, it pops right back to my hand. But there's another thing. If I start the aiming and move the mouse down to the bottom of the screen, this also cancels the aiming. That's new. Now let's see how this works in our game. So in this demo, the first two cards are single targeted attack cards, and the last one is a non-single targeted defend card. So if I start to drag this over, I can drag it around, right click to cancel the movement, and if I release it somewhere, it says play card for target's card drop area, just like before. But for these two cards, if I start dragging them, I can release here or cancel out with right click, it behaves the same way. But if I start to drag it over the card drop area, it animates to the center of the hand and we display this little arc. And I can hover over the crab enemy, release this, and it gets played and it says play card for target's enemy. Perfect. And just to show you, we can also do the right click cancel, just like before. And from the aiming state, if I start to drag it towards the bottom of the screen, this cancels the aiming state as well. Cool. Now let's see how we can do this. So let's open up the project and pick up where we left off last time. In order to tell if we need to aim or not with the cards, we need to find a way to differentiate between the two kinds of cards. If you remember the intro video, we talked about how data heavy this game is and that we can use Godot's resource system to store info about cards, for example. I won't get into too much detail yet because there will be a video dedicated to this topic. For now, let's just say that resources are data containers stored in the file system. So let's jump in and create our first custom resource for the cards. Let's select the root folder in the file system doc, right click, create new, and create a new folder and call this custom_resources. Let's select this new folder, right click and create a new script, and we'll call this card.gd. And we also need to make sure that this doesn't inherit from the node class, but rather this, in this case, from the resource class. Let's press create, expand this folder and double click on the card script to open it. So what's up with this card script? Well, first of all, we do the usual. We define a custom class name called card, so we can use this as a static type throughout the whole project. Then we define an enum for the type of the card, which I borrowed from Slay the Spire, so the cards can be attack, defend, or power cards. And we also have an enum for the target, which can have 4 different values. So a card can target the player themselves, a single enemy, all enemies, or everyone on the board at once. Then we have an export group annotation, so we can nicely couple together the next 3 export variables, namely, we have a string ID for the card, which is a unique identifier. Then we have type and target, which have their values from the enums we specified above. And the cool thing about resources is they're not just data containers per se. We can have functions defined. And it comes really handy because we want to be able to differentiate between single targeted and non-single targeted cards, right? And that's not the card UI's responsibility to decide, or not the player handler's responsibility to decide. If you think about it, the card can answer this question itself. So we'll define a function, and we can call this something like isSingleTargeted, return a Boolean value, and we return whether the target is equal to the target.singleEnemy or not. And that's it for the card script. Okay, so we have the script ready, but this script is not attached to any nodes in the game whatsoever. So how do we use this? Well, if we go back to the file system doc, that's where we can add, delete, and create new resources. So let's select the root folder, right click and create a new folder again. And let's call this characters. Select this new folder and add a new folder. Let's call this the warrior, for example. And if we expand this folder, create one last folder, right click again and call this cards. So we keep things tidy and organized. And for the warrior character, we can create his cards, right? So right click on the cards folder, create new, but this time we'll create a new resource. And if you search for card, you should see that because we define this custom class name for the script. So we can add a new card, and let's call this warrior ox attack. And if we expand the folder, you can see that we created our first card, which is a resource on the in the file system. And again, create a new resource, a new card. And this one can be warrior block. Save this. And to edit the resources, we can double click on them and go to the inspector doc on the right side. And you can see that this export group card attributes is appearing here, right? So we can expand this group and we have 3 properties we can edit. So for the warrior X attack, the ID can be the same, warrior _X _ attack. The type is attack, that's fine, but the target, this will be our single targeted spell. So let's change this to single enemy. And also double click on the block card, expand card attributes, call this warrior block. This will be a defend kind of spell, and the target should be self. Let's press Ctrl S to save everything. And that's all the setup we really need for now. Editing Adam here. So one thing I realized that for the types, I used attack, defend, and power as the 3 possible kinds of cards. And if we're really nitpicking, there's no such thing in Slay the Spire as defend cards because they're called skills. So if you really want to keep the terminology used in Slay the Spire, you can change this to skill. It doesn't really matter that much, I think, but for perfectionists, I realized that this should be skill, not defend. Okay, so if you want to, you can change this and everything should work as expected still. Okay, so now we have our card resources ready to go. And we already added 2 specific cards, the X attack and the block. The question is, who needs to have access to these resources in the project? Well, the card UI definitely does, right? Because if you think about it, the cards displayed in our hands should know which card they belong to. Especially for the aiming state, right? Because it depends on the kind of targeting we have, whether we should go into the aiming state or not. So let's go to the card UI script. We need to add an export variable called card with the type of card, of course. If we save this script and go back to 2D mode and select one of the card UIs, you can see that we have this new property popped up called card and it's empty. So what we can do is we can select the first cards, for example, and drag and drop the Axe attack to them. And for the last one, we can use the block. So we have the first 2 cards will be single targeted attack cards in our hand, and the last card will be a non-single targeted defend card in our hand. Before implementing the aiming system, we'll add a mock enemy to this scene. So we have a valid target to test the aiming system with. But before we do that, let's select the card of areas collision shape 2D. Because at least for me, it's a bit annoying that like 2/3 of a scene is really, really blue. So if we select the debug color property, we can turn the alpha way down to something like this. It looks much better in my opinion. And then we can add this new enemy to the scene. So let's select the battle node, the root node, and click on the plus sign or Ctrl A and search for an area 2D. Let's double click on this and rename it to enemy. And we have the configuration warning for not adding a collision shape yet. But let's add the sprite 2D first, so we can see the image before we define the collision shape. And for the sprite 2D, we could expand the art folder and search for one of the tiles, one of the characters. But it's really hard to see what's going on with these small previews. So I think a better way to do this, in this case, is to expand the drop-down menu next to the texture property and press load. If you go to the alt further, you can see that the previews here are much bigger, so it's easier to pick one. For this one, I'll pick the crab enemy and zoom in to see it better. And now if we select the enemy again, we can add the collision shape, 2D node, and use a rectangle shape 2D for this. Actually, the default looks perfectly fine. It's not a problem if it's a bit bigger when we try to select the enemy with our aiming system. But we also need to make sure we configure this area with the collision masks and layers. If we go to collision, we need to set the layer to a new one because this is neither a card target selector, neither a card drop area. So we use the layer 3. Don't forget to rename this to something more meaningful. We can call this enemies. Don't forget to check layer 3, so we can put this enemy on the enemies layer. But for the mask, card target selector is perfectly fine because for the aiming we'll use this layer too. Well, before we move this enemy to its place, I like to keep things organized in my scene tree. So let's collapse the card drop area and collapse the enemy and use something consistent here. For now, we'll do it this way. All the 2D nodes will be above the non-2D nodes, in this case the canvas layer and all the control nodes, so it's a bit more organized. And if we zoom out, we can move this enemy so it's not on the top left corner of the screen. I press W on my keyboard to enter move mode and move this enemy to, let's say, here. Let's save the scene. And we can play the game to see how it looks. We have the area for the card drop as well, and these are attack cards, but we haven't implemented the aiming yet, so no matter where I release this, it will behave like the defense card should. Cool. So next up, we can set up the card target selector, and we can create a new scene for this. Let's click on the plus sign, and we'll start with the 2D root node. Let's click on this and rename this to card target selector. And just so we don't forget, we can save this scene by pressing Ctrl S. And we can go back to scenes and create a new folder called card target selector. And card target selector.tscn is perfect. Let's save this scene. And we can add the new area 2D as a child to this. And we can also add a collision shape 2D. And this will be like a cursor, which is looking to collide with enemies on the battle scene. So we can zoom in, and we can use a really small collision shape for this. So let's add a new rectangle shape. And if we click on this, we can set the size to something like 4 pixels by 4 pixels, something really small. Okay, it's perfectly fine to have this on the top left corner of the screen, but let's not forget to configure the area 2D node. So let's go back to the area 2D. By default, we won't be using this. We only need to turn this on when we start aiming with the card. So we can turn both monitoring and monitorable off. And under collision, we'll have this on the card target selector layer, because this is used to select the card target. But for the mask, we'll use layer 3, the enemies layer, because that's who we're looking for in the case of single targeted cards. Okay, we can save this scene. So next up, we'll add the card arc visual. And this will be a separate scene on itself. So let's click on the plus sign. And this time we won't be using any of the 3 general purpose root nodes, but rather an other node. And search for line 2D. Click on this and rename it to card arc. And we can save this scene too. So press Ctrl S. Cardarc.tscn is fine. And I think in this case, it makes sense to save this to the card target selectors folder because it belongs to the card target selector. So let's press save. And we can zoom in, and we need to test how our line will look like. So in this toolbar, you can see we have 3 highlighted icons, and the first one is for adding points. So let's click on this button and left click a couple of times to add some points, and we can move them around. So this looks something like an arc. But this line looks boring and way too thick in my opinion, but we can always test how it looks. So if we press run current scene or F6, you can see that this is how it would look like in game. This is way too thick. And we can also make it look more interesting with a width curve. So let's do that. Let's change the base width to something like 4 pixels. Already looks much better, right? And we can also define a width curve. Click on this, new curve, click on the curve. And before creating the curve for this line, let's update the min value. So it won't be too thin either, to something like 0.2. And then we can add the points. So let's begin thin and let's add a new point by left clicking, something like this. And at the very end, we can drop it down again. So I think it looks much better like this, but let's see how it looks in game. So if we run the scene again, okay, that looks much better. It still looks a bit weird because we only have like 4 points, but we'll have more points when we code this, so it will look a lot better later on, I promise. But for now, that's all we need to do, and we can delete these debugging points because we'll set these points from code later on. So if we go to points, you can see that we have all these points here, but if we press this reverse button, it will erase all the points from the array. So we can save this scene, and that's all the setup we need for the card arc. Now if we go back to the card target selector, we need to instantiate the card arc here. So let's select the root node, the card target selector node, and before we instantiate the arc, let's think about this for a second. Because if we go back to the battle scene, you can see that we have the cards here, and we want the arc to be displayed over everything. And if you remember, the battle UI is a canvas layer on itself, and it is on layer 1. So here, to make sure that the arc will be rendered on top of everything, we can add a new canvas layer as a child node. And make sure to set the layer on layer 2. So this will mean that the card arc itself will be rendered on top of everything else in the game. And as a child to the canvas layer node itself, we can instantiate this card arc scene. That's all the setup we need for the card target selector. After completing the card target selector, we can instantiate it in the battle scene. So let's switch over to the battle scene. Select the root node, the battle node, and click on the instantiate child scene button or press Ctrl+Shift+A and search for card target selector. Let's open that scene. And just as before, to keep things organized, we'll drag and drop this over the UI layer. But now we find ourselves in a pickle a little bit because we need to establish communication between the card target selector and the card UI's state machine. And if you think about it, these nodes are pretty far away from each other. That's when I tend to reach for the event bus pattern. So if you think about it and take a look at the scene tree, we have the card state machine and the card target selector, and we need to establish the communication between those two. More specifically, we want to establish communication between the aiming state or the dragging state of the state machine and the card target selector. And we could do something like emitting a signal from the state, emit it to the card state machine, and the card state machine can emit another signal to the card UI, and the card UI can emit another signal to the hand, and the hand can emit a signal to the battle UI, and then finally, at the very top, we can connect those two signals between the battle UI, which has the bubbled up signal, and the card target selector. The problem with this is it creates a lot of overhead. Like, why would the hand need to be aware of handing a signal that the aiming is started or not? It's not the hand's responsibility. So in those cases, we can use an event bus instead. It's pretty simple actually. We have a class, a singleton class, which is the event bus itself. In Godot, we call these auto loads. And the event bus is just a list of signals really. And what we do is we take the card state machine or one specific state and emit the notification. We ask the event bus to emit the notification, to be more precise, that the aiming has been started. and we connect this aiming started notification to the card target selector and any other node who cares about this really. And we don't need to couple the card state machine and the card target selector themselves together. Instead, we use this mediator, the event bus. But you could argue that this also creates a coupling between the card state machine and the event bus, and also the event bus and the card target selector. And that is true, but is it really that bad that the card state machine knows about the game events? Or the card target selector knows about the game events or the signals we have? I think that's a worthy sacrifice to avoid bubbling up signals to 3 or 4 levels up in the same tree. So that's what we're going to do for this example. But keep in mind that that's just one way of doing it. So to create the event bus, we go to the file system doc and create a new folder under the root folder. And let's call this new one something like global. And if we collapse the art folder and all the other stuff we don't need right now, you can see we have a new folder called global. Right click, create a new script. And let's call this one events. Create the new script. Double click this to edit it. And we can delete all the auto-generated code. And as the project grows, we'll have a lot of different game events or signals here. But for now, we really just need 2 for the dragging mechanic. So we'll call these card-related events as a group of signals, and we'll have a card aim started signal and the card aim ended signal. And we pass the card UI nodes as parameters, so we can get access to them from the card target selector node. Let's save this script. And don't forget to register it as an auto load in Godot. So to do this, we need to go to project settings, auto load, and click on this folder icon. Go to global, events, open the script. We'll have a node name, a class name attached to this. Events is perfectly fine. Click on add and make sure that the enable checkbox is on. And we can close the project settings. And that's really all there is to creating an event bus. Next up, we can implement the card aiming mechanic finally. We'll do this in 3 steps. First of all, we should add the new aiming state to the state machine. So let's go back to 2D mode and click on this open in editor icon to open the card UI scene. Select the card state machine, hit Ctrl A or the plus sign and add a new node. Double click and rename this to card aiming state. Attach a new script to this, just like we did before. Go to the correct folder, card states, and rename this to card aiming state. And as you can remember, we need to make sure that it inherits from the card state class. Create this new script, and we can delete all the auto-generated code. So how do we handle the aiming state? First of all, we define a constant, and I call this mouse-wise snapback threshold, which is in pixels. If you remember the Slay the Spire demo, if you move the mouse all the way down to the bottom of the screen while aiming, it cancels the movement. And we'll check if the mouse position is below this threshold or not, and if it is below, then we cancel the movement. Okay, so what do we need to do when we enter the aiming state? Well, first of all, we do the usual. We set a debugging color and text to see that we entered aiming mode, but also we need to clear the targets array of the card UI. Why? Well, because if we enter the aiming state, it doesn't matter if we had any previous targets, for example, the card drop area or not. We need to clear this area to make sure that the only targets we can have while aiming are enemies. Then we calculate the offset for the card because we need to animate it to the center of the hand. And to do this, we'll need a bunch of new stuff. So for example, we need to have access to the current parent of the card UI, which we haven't defined yet in the card UI class, but we'll do. And also we need to create a function for the card UI, which animates it or tweens it to the center of the hand. And also we can set the monitoring property of the drop point detector to false, because when we are in the aiming state, we don't really care about moving the card over the card drop area. Actually, we want to turn this off so we don't get false targets, because the card drop area for a single targeted spell is not a valid target, right? So we need to turn this off. And if you remember, that's why we needed to turn this back on when we enter the click state, when we start to interact with the card. Then we use the event bus, because we arrive at the point where we did everything we need to enter this aiming state. So then we can notify the event bus that, hey, you should fire this signal card aim started, so the people who care about starting aiming can listen to this event. So later we can connect this signal to the card target selector, and we can display the card arc on the screen. Then when we exit the state, that's the first time we override the exit function, by the way. But this time when we exit the state, we can say that the card aim has ended. So we can again ask the event bus to fire this signal. And the aiming itself happens on the input callback function. So first of all, we define two flags, one for the mouse motion and one for checking if the mouse position is below the snapback threshold we defined on the top as a constant. And then we check if we move the mouse and the mouse is at the bottom, or if we press the right mouse button to cancel out the movement, because both of these mean that we should immediately head back to the base state. Else, if we somehow finish the aiming process, meaning release the left mouse button or press the left mouse button again, we can set the input on the viewport as handled to make sure that no one else picks up this input event, and also go to the release state. And that's all there is to it for the aiming state itself. Save this script. And if we go back to the 2D view, let's not forget to set up this aiming state in the editor as well. Because if you remember, we need to set the state this node represents. So if we go ahead and select the card aiming state, we need to change this to aiming. Okay, now let's save this scene. And that's step 1 complete. Step 2 is to change the card UI script, because we have no animate to position function, and we also have no member variables we need for the tweening and accessing the parent for the animation itself. So let's go ahead and click on the script button attached to the card UI. Introduce the two new member variables. For the parent, it will be a control node definitely, and the tween will be a tween variable. Then we'll also need the animate to position function with two parameters, the new position we need to animate to, and the duration of this animation given in seconds. And in the function itself, we'll create a tween, set the transition and the easing to anything you like. You can use this cheat sheet, and then we can tween our own global position property to the new position for the given duration we have. And that's step 2 completed. But while we're here, we need to do a bit of a tweaking for the hand script as well. So let's not forget to assign this parent variable somewhere. Let's go ahead and hit Ctrl-Alt-O, search for the hand script. And all we need to do is right here, when we connect the reparent requested signal, we just add a new line and set the card UI's parent property to ourselves as the hand. And with that done, save this script, and we can do the last step to hook up the aiming system. So the final piece of the puzzle is to fit in our new aiming state to the current state machine. How do we do this? We have our state machine from last time, and we introduce this new aiming state to the mix. So which state can we go to the aiming state from? The only place that makes sense is the dragging state. And from the aiming state itself, we can go back to the base state by cancelling the aiming mechanic, or go to the release state when we have successfully selected a target. And what are the conditions to do the transitions? To go from the dragging to the aiming, we need the card to be a single targeted card, mouse motion needs to happen, and the card needs to reach inside the drop area. From the aiming, to cancel the movement and go back to the base state, we need to press the right mouse button or recognize that the card is under the Y threshold we provided earlier, so we can cancel the aiming and go back to the base state. And from the aiming to go to the release state, we either press the left mouse button again with one form of aiming, or if we use the drag and drop mechanic, then we released the left mouse button. So let's go ahead and implement the changes. To do so, we need to open up the dragging state. So press Ctrl-Alt-O, search for dragging state. So in the input event callback function, we need to do a bunch of stuff. First of all, we'll define a new flag called single targeted, which will call the card UI's card resources single targeted function. This is why it's good to have this card resource attached to the card UI, because we can access information like this. And then what we do is, before doing any of the stuff we did earlier, like canceling the dragging or going to the release state, we'll set up a new if statement for the 3 conditions we have. Single targeted is easy because we just made a flag for this. Detecting mouse motion is easy because we already had a flag for this. And to detect if the card is above the play area or not, we can check the card UI's targets array. If its size is bigger than 0, meaning it has an element added to the array. And if you think about it at this point of interacting with the card, this target we have in the targets array cannot be anything else but the card drop area. Because we haven't even started the aiming process yet, right? So it cannot be an enemy, because the drop point detector only looks for the card drop area as a collision. So if we are above the card drop area, then we immediately request a transition into the aiming state and return from this function, because if we are going to the aiming state, we don't really care about all the canceling the dragging and stuff anymore. So we pass the baton to the aiming state to handle what's coming next. And that's all there is to hooking up this new aiming state from the dragging state. And let's run the game to see what we have so far. So if I play the game, remember the first 2 cards are single target attacks and the last card is a defend card. So if I start to drag around the defend card, it behaves as expected. I can release it in the card drop area, inside the card drop area. But if I start dragging this attack card, I can release it under the card drop area, and it does the same thing. But if I start dragging it and drag it up to the card drop area, you can see that it goes to the aiming state, properly gets animated to the center of the hand. And we go to this aiming state, and if I release the mouse, well, nothing happens except for it goes back to this base state. Perfect. Now we need to hook up the card target selector system to this aiming process so we can display the card arc at the mouse cursor. That's what we'll do next. For the card target selector, the first thing we need to do is to attach a script to it. So let's go back to 2D view. Select card target selector as the root node. Press attach script. Card target selector.gd is perfect. Click create. And we can delete the auto-generated code as per usual. Okay, so what do we need to do here? Buckle up, because this is a bit of a longer script. So first of all, we define a constant called arc points, which I set to 8, but you can experiment with different values. This is how many points we sample between the card's position and the mouse position to create the arc. 8 works perfectly fine, I think, but you can, again, experiment with the values. Then we reference 2 already variables, namely the card arc and the area 2D for the collisions. Then we'll also have 2 member variables called current card, which is a reference to the card UI that is included in the aiming process, and the flag to track if we're in a targeting process or not. Then in the ready callback, we connect the event bus's card aim started and card aim ended signals to our own functions. This is how the event bus works. This is how we were able to decouple the card target selector from the card UI's state machine. Then in the process function, if we're not in the middle of a targeting process, we can return because we don't need to do anything. We can say that the card target selector is sleeping in that case. But if we are targeting, then we need to update the area 2D's position to the mouse position and calculate the current points for the card arcs line 2D. For this, we'll have a local function called getPoints. The getPoints function returns an array of vector 2s. First of all, we define an empty array for the points, and then set the starting position to the current card's global position, and we offset it on the x by half of the card's size. Why? Because we don't want the card arc to start from the top left of the card, but rather the top center. We set the target to the local mouse position, And we calculate the distance between the two vectors by subtracting them from each other. And then we start a loop for the range of the arc points we have. We sample all the points, we calculate their coordinates and apply an easing function to the points. More on that a bit later. Then we append this newly sampled and transformed point to the points array. And finally, after the loop, we append the end point, the target point, the mouse position as a last point to the line 2D. And then we return from this function with the array of points. This easing function I was talking about looks like this. Why do we need this at all? Let's say we calculated the distance between the two vectors and we got this straight line. We can assume that 0, 0 is at 0% of this line, and 1, 1 is the end of the line, which means we traveled 100% of the distance. Now we can split this distance into, let's say, 5 perfectly distributed points. So we can say that the first is at 0, 0, the second will be around here, the third will be around here, the fourth is somewhere here, and the final one is at 1, 1. Okay, but we still have a straight line. That's where this 1 minus x in parentheses on the power of 3 function comes in. If we apply this function to the same points, you can see that this straight line we have transforms into a nice arc with the same 5 points. 0, 0 will be at the same place, but we can see that the second point will be here, the third point will be somewhere here, the fourth point will be here, and the last point, 1, 1, will be at the same place. And these 5 points transformed into an arc from the straight line. After the easing function, we can handle the two callbacks, the card name started and card name ended callbacks. In the case of card name started, we'll first check if the card is single targeted or not. Because if we emit this card name started signal with a non-single targeted card, something really messed up happened, and we shouldn't engage in aiming at all. So we can return from this function. But if it's a single targeted card and we need to start the targeting, we set the flag to true. We set the monitoring and monitorable properties of the area 2D to true as well. And we set the current card to the card we passed on to this signal. And similarly, we need to handle the card name ended event. And so when the card name has ended, we set the targeting to false. We clear the points for the card arc so the line gets hidden. We set the area 2D back to the top left corner of the screen, turn off monitoring and monitorable, and set the current card to null. But we also need to connect the area 2D entered and exited signals to this function so we can properly register if we selected an enemy or not. To do this, we do two things. So when we enter an area which is an enemy, first we check if we have a current card and in the middle of a targeting process. Because if either of those are false, then we can return from this function because we don't really care what the card target selector does. But if we have a current card and we are targeting, and the current card's targets area doesn't have this enemy yet, then we can append it to the valid targets of this card UI. Similarly, when we exit a 2D area, we don't really need to do anything if we don't have a current card or we are not targeting. But if we are targeting, we can erase this area, this enemy, from the current card UI's targets array. And that's all there is to it for the card target selector. But don't forget that these two functions need to be connected to the area 2D signal to work. So let's go back to 2D view. Click on the area 2D. Go to the node dock, select signals, double click area entered. Press connect. The name should be matching, so we see this green icon. And do the same for area exited too. Let's save the scene and the script. And if we play the game, should be able to start aiming. And you can see with the visible collision shapes debug option enabled that this 4x4 small area gets dragged around. And if I release it over the crab enemy, you can see that we no longer target the card drop area itself when we release this, but we target the enemy itself. For the defense card, for the skill card, we can still use it as before. So when we release that card, we'll still see card drop area. Then we go to the aiming state. We can target the enemies finally. And you can see that right-clicking works as expected, and also dragging it towards the bottom cancels it too, just like we expected and saw in the Slay the Spire demo. Awesome. So we're almost done with this tutorial, but we have yet again a rather annoying and hard to spot bug. Let me show you. So when we run the game, first of all, let's get rid of the skill card. And if I start dragging this attack card, it gets snapped to the center and I can start aiming, the arc looks fine. I can cancel it out. Everything looks perfect, right? Well, the thing is, if I start, for whatever reason, if I start dragging this card and drag it down real fast when entering aiming state, oh, take a look at this. The card gets stuck in that position, even though it's in the base state and it should be technically be in our hand. And if I start dragging and interacting another card, it goes back to its place, but again, we can get it stuck here. Why? Why is that? Why on earth? If you think about it, it takes 0.2 seconds for this animation to finish, to snap it back to the center. And if we do the transition from the aiming state to the base state faster than the 0.2 seconds before the tween animation can finish playing, then the card gets stuck here. Fortunately, that's a relatively easy fix. Let's see how we can do this. So this thing happens when we enter the base state. So this is where we will tinker with the code. Let's press Ctrl-Alt-O and open up the base state. And what we can do before all the reparenting and recoloring stuff is to write an if statement, checking if the card's tween exists and is running at the same time. And if both of those are true, we can kill the tween animation, which stops it immediately. And with that little change, if we save this and run the game again get rid of the skill card, you can see that no matter how fast I try to do this again, the card no longer gets stuck in this position. Okay, so that's it for this video, and see you in the next one. Bye bye.